In the last video, we talked about the three basic trigonometric functions. We're going to elaborate or expand on those today, and we're going to talk about the reciprocal trigonometric functions. We're just going to jump right into it. And so we have three reciprocal trigonometric functions, and they are the cosecant, the secant, and the cotangent. Cotangent, notice we hear tangent right in it. Three reciprocal trig functions, and then we're going to have their inverses the same way we did for the trig functions, the three basic ones. But let's see how these things work. Well, the reciprocal trig functions are reciprocals because they're the reciprocals of the trig functions we have already defined. And cosecant, which we abbreviate CSC, is the reciprocal trig function for the sine function. What that means is that sine of an angle theta is equal to 1 over cosecant of that angle theta. They're reciprocals. Secant, which we abbreviate SEC, is the reciprocal for cosine. And then cotangent, if you didn't figure it out by now, we'll abbreviate it COT, would be the reciprocal for tangent. So tangent of theta is equal to 1 over cotangent theta. What I started to write there is cotangent theta is equal to 1 over tangent. It's also 100% true. Think about a reciprocal, it works in either direction. So I can switch all of these around to give me another true pairing. And so the same way we had those trig functions defined, I said these are just definitions, we just need to memorize them. The reciprocals are just definitions as well. They're defined as a reciprocal of the other trig functions. We just need to have them memorized. And so just know how they pair up, right? Kind of just need to know one of these lines, top line, for instance. Sine pairs up with cosecant, cosine pairs up with secant, tangent pairs up with cotangent. You need to know those. And the easy way that I have to remember it is that every pairing needs a co-partner. So think cosine, cosecant, cotangent. We have three cos and three non-cos. So sine does not have a co, it needs a co-partner, gets cosecant. Secant has no co, needs a co-partner, cosine. And then tangent needs a co-partner, cotangent. Cotangent and tangent, I believe, should be the obvious ones. So again, if we think about sine we defined as the opposite over the hypotenuse. We can define the cosecant function as the hypotenuse over the opposite. So we can think about these reciprocals in terms of either its reciprocal partner, sine, cosine, or tangent, or in terms of the ratio of sides, because these are still trigonometric functions. They still are taking an angle to a ratio of sides. It's just they're doing it in a opposite way that the sine, cosine, and tangent did. So cosecant would be hypotenuse over opposite. Secant would be equal to the hypotenuse over the adjacent, and then the cotangent of theta is equal to the hypotenuse, so it's not at all, the adjacent over the opposite. Sorry, I just got careless there saying hypotenuse each time, but the tangent does not have a hypotenuse. Tangent is opposite over adjacent, so cotangent should be the adjacent over opposite. Also, I didn't mention this in the last video, but I do want to stress it here. Notice whenever I write the trig function, I always write the trig function of the angle. Never leave off that angle, because that would be equivalent to writing square root. Square root of what? I have to have a number inside of it. I have to have an angle inside of it. So these are our three reciprocal trig functions, cosecant, secant, cotangent. It shows what their ratios are. But I think a lot of times, I'll go back to that first line, it's much easier to think about them just in terms of what are their partners. They're going to be important. They have uses. We need to be comfortable with them. But it's real helpful to think about them just in terms of their partners. So, for instance, if I were to ask you, what is the secant of 15 degrees? What is that equal to? Well, notice on the calculator, there is not a secant button. And there's not a cosecant, there's not a cotangent. So I see secant, I just know that's 1 over cosine. So if I type 1 over cosine of 15 degrees into the calculator, it's going to give me the answer. Just like we talked about with the trig functions, we've got to make sure the calculator's in the right mode, so always double check that. In this case, we're in the degree mode, and so secant of 15 degrees, or 1 over cosine of 15 degrees, would be equal to approximately 1.04. And I should switch this to an approximation sign because we are approximating when we put in the calculator. If we take cotangent of, let's say, pi over 15, well, now we need to make sure that our calculator is in radian mode. When we type this in, we're going to be typing it in as 1 over tangent pi over 15. So pi up front there. So if we take the pi over 15, put it inside tangent, put it on the denominator of a fraction, we should get 4.7 and 0 when we round it out. And again, that's an approximate. So just to apply these directly to the triangles that we've been dealing with, let's take one example where we can solve the triangle. So I have a right triangle here. Let's say that we know the angle is, we'll say 34 degrees. I'm going to say that the opposite side is 15 units, 15 feet, 15 miles, whatever. And let's solve for all the other pieces. And so if I look at this, the first easy thing to solve for, angle B. We don't have to use any trig. 180 minus 90 minus 34. I'll have some people ask me, well, can't I just take 90 and subtract 34 rather than doing minus 90 minus 34 every single time? Yes, you can, but the danger with that is once we move to non-right triangles, don't keep doing that. So that's one of the reasons I almost always write out the 180 minus, just so we don't get in that kind of lazy habit of taking 90 minus the other angle. And so when we do this, we should get 56 degrees. And that's the easy one, right? Get that right away. Let's move on to side C and side B. Let me start with side C just for something different. And so if I think about what I started with, again, I could use the 56, but I'm going to just use what I started with, the 34, the 15, and the C. C is the hypotenuse. So I have the 15 is the opposite hypotenuse. I'm going to have to use the sine. So I could set this up as sine 34 is equal to 15 over C. And notice I would have to multiply the C out of the denominator. And then divide by the 34, the sine 34. So we've kind of added an extra step in that I had to get the variable of interest out of the denominator first, and then that meant taking the sine and dividing it back across. What if I instead just said, I want to end up with the variable I'm looking for on the top? Well, I could have done that. I could have said, well, let's take the cosecant of 34 degrees, and that's equal to C over 15. It's just the opposite ratio. Then to get the C by itself, all I have to do is multiply the 15 to the other side. So that's still perfectly true. But then we'd still run into the problem of I can't type this into the calculator directly. I'm going to have to turn this cosecant into a 1 over sine. And that puts us right back to where we were. So again, it's just another way to look at the problem, and this can be useful, especially when we're not forced to using a calculator, right? This saved us a step. One step, we got to the answer very directly. To get the approximated value using the calculator, that's when we had to add another step. But hopefully we're beginning to see where these things might be of interest, because they do allow us to place the variable desired into a given position, right? And that's kind of useful. Just to finish out the problem, if we were to take 15 over the sine of 34, make sure your calculator's back into degree mode. Can't stress that enough. Make sure your calculator's always in the correct mode. We get 26.82. And again, that's a side, so it would be feet, inches, miles, whatever our units are. That is larger than the 15. That's good so far. We'd still need to find side B. If I wanted to do that with the original 15, I could use tangent very easily. So I could set up tangent of 34 is equal to 15 over side B. Notice I'm ending up with that problem again where B is in the denominator, so I have to multiply it over just to divide by the tangent of 34. Where I could have, if I'd wanted to, set up a cotangent and had that be already in the numerator, then multiplied the 15 over. But because we're going to use a calculator, we're still going to need to move that tangent to the denominator, write it as 15 over tan 34. And so when we do that, we get 22.24. And that should be the second largest. Notice 26 is largest. That was our C, the hypotenuse. 15 opposite than 34, the smallest angle. That is the smallest, and then 22 slotting into that middle tier. So again, we do just need to kind of memorize definitions, or at least know how they match up. A lot of times when I'm using the reciprocal trig functions, I purely think of the original. I think of sine, cosine, tangent, but you have to know how they match up. So you've got to, at the very least, have that memorized. Just like with the trig functions, every day that goes by that you don't know this, it's another day you're falling behind. So really sit down, just have them memorized. If you have any questions, let me know.